Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the example 3 for the Boolean function simplification using 3-variable K-map for a POS. So my students, in the lecture number 83, we had discussed the different rules for POS solution. Those rules include pair reduction, quarter reduction, octet reduction, map rolling reduction, overlapping group and redundant group rules. And in the last two lectures, we had discussed two examples considering this Boolean solution using a K-map for POS. So my dear students, in this lecture, let us consider the third example. Our question is simplify the Boolean function using a 3-variable K-map. The function is a plus b plus c bar into a plus b bar plus c bar into a bar plus b bar plus c into a bar plus b bar plus c bar. So as we can see in this function, there are three different variables. Those variables are a, b and c, and all the individual terms has all these three variables. So let us consider the function one more time. Our function is a plus b plus c bar into a plus b bar plus c bar into a bar plus b bar plus c into a bar plus b bar plus c bar. So if we are converting this function or this individual terms into the max term representation, a plus b plus c bar can be represented in max term as 0, 0, 1. A plus b bar plus c bar can be represented as 0, 1, 1. That is, a variable is represented in max term as 0 and a variable complement is represented as 1. So that's why a plus b plus c bar is represented as 0, 0, 1. So a is represented as 0, b is represented as 0 and c bar is represented as 1. And the second term, a plus b bar plus c bar, a is represented as 0, b bar is represented as 1, c bar is represented as 1. In the third term, a bar, b bar, c is represented as 1, 1, 0. And finally, a bar, b bar, c bar is represented as 1, 1, 1. So that is, this individual max term 0, 0, 1 is equivalent or can be represented as EM1. 0, 1, 1 can be represented as EM3, 1, 1, 0 is EM6 and 1, 1, 1 is EM7. That is, the final representation of function in max term is EM1 into EM3 into EM6 into EM7. This is equivalent to pi of 1, 3, 6, 7. That is, a given function can be represented as pi of 1, 3, 6, 7. So as we all know, this function is considering three independent variables. Thus, we have to use a K-map with 2 raised to 3 variables. So 2 raised to 3 is equal to 8-cell K-map. So we are using an 8-cell K-map in this problem solution. So since we are using 8-cell K-map, we can see 2 different rows and 3 different columns. The rows represents the variable a and the column represent the variable b and c. So next what we have to do is mark 0 in the cells with the max term representation. That is, in the given function, the function is pi of 1367. So what we have to do is mark 0 on the cell position 1, cell position 3, cell position 6 and 7. So we are marking 0 in 1, 3, 6 and 7 cells, and the remaining cells, that is the cell number 0, 2, 4 and 5 are marked with 1. In the next step, we are starting our reduction. So we are applying the pair reduction for the cells 1 and 3. So here we are applying the pair reduction for the cell 1 and 3, and which is marked in the blue color representation. And secondly, we can see another pair is 6 and 7, cell 6 and 7, which is represented in red color. Here we are avoiding the redundant pair. The redundant pair is cell 3 and cell 7, since these cells are covered in the first and second pair. So we have 2 different pairs. The pair 1, that is cell 3 and 1. So second pair, that is pair 6 and 7. So next what you have to do is reduce these pair as per the different laws. So if we are considering the first pair, that is a pair number 1, which is represented in blue color with the cell 1 and 3. This pair lies in the first row and it lies in the column number 2 and 3. Since it lies in the first row, the value of a in row 1 is 0 and which is unchanging. Thus we have to consider the value of a since the value of a is not changing. So as we discussed in lecture number 83, we are considering only the variables which are not changing, and we should avoid all the variables which are changing in the K-map solution. When we come to the columns, that is the variable b and c, in the column number 2 the value of b is 0 and the column number 3 the value of b is 1. Thus the value of b is changing and we have to avoid the value of b, and the value of c is 1 in both the columns 2 and 3. Thus the value of c can be considered for the final output. Thus the first pair can be reduced as a plus c bar. If we are considering the second pair lies in the column 3 and 4 and in the row second. So in the second row the value of a is equal to 1. Thus the final reduction can be considered as a bar plus, and the column values are b is not changing and c is changing from 1 to 0 in column 3 and 4. Thus we are considering the value of b only and ignoring the value of c since the value of c is changing. So the value of b is 1 in column 3 and 4. Thus the final max term of the second pair is a bar plus b bar, and the final POS can be written as ANDing these individual terms, that is POS is equal to a plus c bar into a bar plus b bar. So my dear students, we had got the question to solve a plus b plus c bar into a plus b bar plus c bar into a bar plus b bar plus c into a bar plus b bar plus c bar, which we had reduced as pi of 1367, and we marked those values in the K-map and solved, and the final POS for the given function is POS is equal to a plus c bar into a bar plus b bar. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our assignment question is: simplify the Boolean function f of x, y, z is equal to pi of 0, 1, 3, 5, 7 using a 3-variable K-map. So my dear students, by this lecture we are completing our 3-variable examples for the POS representation. In the upcoming lecture we will discuss the Boolean function simplification using 4-variable K-map for a POS. So dear students, see you soon. Until then, goodbye. Thank you and all the best.